Well, welcome to a short and sweet lesson for video. As you can see, or as you can stop and back up the lesson, I will be going through this once and quicker than in class, as you can decide when to pause for notes. We will have a mix of computer and paper items for this lesson. Today we'll be discussing the momentum test. First of all, you should remember that conservation momentum states that in a closed system that you will have the same values at the beginning and at the end. In our classroom labs, where we have two dynamic carts, cart 1 with the little plunger, that will collide elastically or inelastically, cart 2, no plunger. Elastic means they bounce off each other. Inelastic means they hit and they stick together. So with that in mind, when they come together, you can see that the carts change velocities or stick together, thereby change the mass. If the two bounce off each other, boing boing, they both go into different velocities at the end. They stick together, they became one big cart. Now for the math, as you can see, momentum is represented with the letter P. M sub 1 means the mass of object cart, in our case, the one with the spring cart. So mass 1, in our case, is cart 1. Mass 2 is object 2, in our case, cart 2. No spring plunger. Momentum is mass multiplied by velocity. I try not to say mass times time, because that might get you confused, or times velocity, because you might get confused and square something, which is mass multiplied by velocity, or P multiplied by V. P equals M times V. Therefore, the mathematical representation is your initial velocity is equal to your final velocity. So if you have a mass moving, then you have momentum. That would equal the mass final times its momentum. Now if you have multiple objects, then you get multiple sets of letters for this, such as here, we have the inelastic collision. That means they hit and stick, in which case we have mass 1, velocity 1, plus mass 2, velocity 2. This would be the momentum initial. Afterwards, the masses come together, and you end up with a final velocity for both. And once again, mass 1 is object 1, in our case, the plunger cart. Mass 2, object 2, in our case, no plunger. Velocity before the collision, and then velocity before the collision. And then, of course, we'd have the combined masses, so we might have them come together like this, and then just keep going that way. That would be the velocity afterwards. And once again, you can see that the two could become one. That's how we've been doing multi-math here. Now, in theory, I could have started off like this, had an impact, and made them go apart. We don't do that problem much. And last, we have the elastic collision between two objects, which is mass 1 v1 plus mass 2 v2. So that means these two start off with a velocity and bounce off each other. Afterwards, they have different velocities than when they started. That would be your mass 1 v1 prime. This prime tells you that is the velocity of cart 1 after the impact. Mass 2 velocity 2, this means this is the velocity of this car, no plunger, after the impact. That's what that prime thing is standing for. And once again, we have the list right here of what stands for what. Now, one of the things you can do before you take a test is pull out their cards, and you can say, okay, momentum initial is this. It's going to equal the final, so whatever's over here is different, but you at least know what the numbers are supposed to show up to. With an inelastic collision, you have mass 1, velocity 1 equals mass 2, velocity 2 equals mass total, velocity final, as we've seen before. And, of course, mass total is m1 plus m2. And you could solve for velocity final, which is m1 v1 plus m2 v2, the mass beforehand, divided by how much mass was involved, will tell you how fast it's going. That would be your inelastic collisions. Should these be on your book cover or some sort of note sheet that you're allowed to use in the test, or better off in your head if you can do the math, but take it as we go it. I could also solve for the initial velocities, v1, if I knew the velocity 2 and the total masses. I could also solve for v2. So what happens is all these equations need to be somehow where you can find them in a hurry during the test. So this would be for carts that hit and stick. The carts that don't hit and stick, you have a much bigger collection, because we start off with this, which is mass 1, v1, velocity initial, plus mass 2, velocity initial, equals mass of the first cart, the velocity after the impact, plus mass 2 and the velocity after the impact. Now if I want to solve it, I can solve this one for v1. So this collection needs to be on right there. You don't need to keep repeating the top part, but you'd have that a collection of things. Now what would be the velocity after the impact? Once again, you start with the same formula, rearrange it for velocity prime, which means velocity after the impact. Again, I could rearrange it for velocity 2, or the second item, after the impact. The formulas look similar, but once again, you just solve it for the correct letter. Here's what the velocity of the second object is after the impact. Now if I want to do the mass, I have to once again start with the starting formula. Now I'm going to move mass 1 onto one side, mass 2 on the other, so I end up with this version of it. Then I factor out mass 1 and mass 2, and at the end I can just divide by which one I like. For to get mass 1, I end up with, it's the fraction divided by mass 2. And of course here's mass 2's. And you'll notice the formulas are very similar. These flip when I flip it around because I started with that version. Now hopefully that didn't go too fast. If it did, back up the tape, or whatever you call it now, the recording, and continue and get what you need. So when we go to fill this out. Now, on the first part of the test, you are not supposed to be using your note card or any kind of notebook cover, because it's supposed to be, do you know your own name, the date, the book number? You state the law of inertia from memory. The body in motion will remain in motion. The body at rest will remain at rest unless acted upon by an outside force. What's the other name? Newton's law. What does the word conservation mean in reference to the law of nature? That the value of whatever you start with will be the same afterwards as before. Now, if you like to be long-winded, you can keep going. And this is just to help you if you don't understand. For example, if you have 2 Newton seconds of momentum before a collision, you'll have 2 Newton seconds of momentum afterwards. However, the velocity of the objects may be very different than the starting values. Same is true of energy and matter. You may start with one amount of matter and have less matter, that is, but a whole lot of energy. However, the total values will be the same. That means whatever mass you lost became energy, or if you do it the other way, whatever energy became mass. You don't get something for nothing. It all adds up the same. What is momentum? The simplified version is how much something wants to keep going. It's calculated using the formula momentum equals mass times velocity, or P equals mv. You will have the same value as the impulse to use to get a body in motion. You just needed to have the first part of the test, but this gives you a little bit more. When we turn the page, what is impulse? Simplified version is how much something resists a change in linear velocity, or how much it takes to change its tendency to keep doing whatever it was doing. It's calculated using the formula of I for impulse. I'm using IMP here because the I is also used for current in electricity, which we'll get to later, which is multiplied by force times time, or impulse equals force Ft. We'll have the same value as the momentum for the same body in motion at a certain velocity. We'll get to this later. This becomes Newton's second law. What is the formula to calculate the value for momentum? P equals mass times velocity. Impulse, imp is force times time. And mind you, you're writing the simplified version before, and that takes care of that part. Now we start going to the second page. You're supposed to do this from memory. Conservation momentum, elastic, where they bounce off each other, is the long formula, because I have masses and velocities at the beginning, mass and velocity at the end, and the masses are separate. That means they didn't stick together. When they stick together, I had 2 cars beforehand, 1 car afterwards. And I could go the other way, but most of the time we go this way. What does it say on conservation momentum? Well, whatever momentum you have at the start, you have at the end. And once again, for example, if you have 2 Newton seconds momentum before the collision, you have 2 Newton seconds momentum afterwards. Then we have the test problem. I can fold this for you.